Hey everyone, Rob here from Rising Edge Industries, and I'm going to do another quick demonstration. This is going to be a single channel demonstration at 500,000 samples per second, so the max speed of the device in single channel mode. And so let's get started. If you want any more detail on the tools or the device, go to the website risingedgeindustries.com, and there's preliminary data sheets and information up there that explains a lot of this other stuff, as well as more demonstrations and tutorials. And so we'll get this started first by opening up the USB link and getting the current configuration, and it's already preset from other testing at the settings we want. So just to change those, I'll set the default config. We'll check it out. It's 10 Hertz channel A0 and A1. That's just the preset, so you can see that changed okay. So we'll go back to our settings we want to test with. Single channel 500K, run to that memory space, and you see the battery voltage is got it's real-time monitoring right here, and so the device is up and running, no problem. So we're just doing a quick bench test. We'll do a sector erase of just the first two sectors of the device, just because it's quick and easy rather than erasing the whole memory space. Reset the device just so it's ready to start over from memory address 0. And that's really implemented just for a bench testing, stuff like that. So we'll kick off the recording engine with the start command, start recording. Now download data, and you see our data is downloading 100 blocks at a time, and so that's 6,200 data bytes at a time, and it only takes a couple seconds to download. Then we'll use a plotting tool, check out the plot. This is a 1 kilohertz square wave, and so it's about 0 to 3.1 to 3.15 volts. Just to look at the oscilloscope. I'll have some more data in the write-up. There's a write-up at Rising Edge Industries that goes along with this video, so go over there and check that out. So now the data file is done. We'll look at that, and just to go over some of the raw data real quick. You can see that our sample is about 3,800. 3800, and so that correlates to about 3.1, 3 or 4 volts. This is a max sample size of 4096. It's the 12-bit sample, so the highest we can go is 4096. So if this rectangular square wave was 0 to 3.3 exactly, we'd have 4096, but it's a little low, so we get 3860 and change, 3880, and so you can see a transition here, falling edge. Now it's at 0, and it'll go back down. It'll transition back to a rising edge. You can see you just catch the very bottom of it, and then it goes back up to that's kind of just below the peak, and then we're back up to normal. So now let's plot this data with a plotting tool, and I just developed this plotting tool to kind of work through some of the proving out of the data integrity and checking data files real quickly. And so paste that data file in. We'll run the launcher and bring that over here, and this will launch a thread to plot the single channel 500K, run, plot that. And so this is what the data file looks like plotted with this little plotting tool, and if we zoom in, you can actually get a much better look at the waveforms. It makes a lot more sense. You can see 0, rising edge, and catch a couple samples on the rising edge, peak, falling edge, and it just goes back and forth. And so data looks pretty good. It looks like a square wave. We can see we're right up around 3800, 3900. We zoom in a lot. And so now real quick we'll check the integrity of the data, and so we'll run through some quick calculations here, because the square wave is at 1 kilohertz, so we want to make sure that our data is coming in at 1 kilohertz and nothing's getting pushed back in time. And so to do that, we'll check out the data file again and run a quick calculation. So we'll look at 1/2 cycle of the data file, which should be about 250 samples. So we'll start about 158 from that last rising edge and go down to here, say 408, open up calculator, 408 minus minus 158 is 250, times 2 is 500, and open up another calculator. So we've got 500 samples that represent our square wave evenly spaced, and so if we then multiply this by the time in between samples, you've got 1 over 500,000, our sample rate, and then you multiply that by 500, and we've got 0.001 seconds, which is 1 divided by 1,000, 1 kilohertz square wave. And so the data looks good, the timing looks good, everything's coming in on time into the memory space, and then it's brought out of the memory space. The integrity, I've got one a demonstration to prove out data integrity. It's with 4 channels, and I'll probably have data integrity demonstrations for every channel. And so go to the website to check that out. It's basically some custom firmware that pushes a counter into the memory space so that you can see a sequential step through memory, pull that data back out, and then use some of my custom tools to check that data file. And if you want the source code to check that out, you can feel free to let me know, and I can put the source code up, link it, just so you can go through it and make sure that you're comfortable with that. It's a pretty robust integrity check. But that's it for now. If you have any questions, go over to the website, get in touch with me, and thanks for watching.